Hello, so today we are going to do this problem, my calendar 3, part of Leetcode October challenge. What the problem says is we have, basically it's my calendar 3 here, and the definition of a K booking is when K events have some non-empty intersection, right? And we get some events that are noted by start inclusive and end not inclusive, right? So basically an event starts at start and ends at end -1, exactly, right? And after each given event, we want to return an integer k that represents the maximum k bookings between all previous events. So basically, k is basically the maximum number of events that intersect in so far. Yeah, that's pretty much it. So it will be a class like this, and we has one main function, book, with start and end, and what we want to return is an integer k representing the largest integer such that there are k booking in the calendar so far, right? So one booking may increase it or may not, right? So that's the problem here, and the range is quite big, 10 to the power of 9. So that tells us we can do something with a loop from the numbers between for all the from start to end, for example. But one thing here is that the number of calls to book are not too big. It's just 400. Yeah, so that's the problem. Now let's see how we can solve it and maybe use this constraint to our advantage. Okay, so let's take a look at this here. Let's try to draw the first example and see what it looks like. So first we book 10 to 20. Maybe let's say 10 is here. 10 to 20. And then we book 15 to 16. Maybe 15 is somewhere here. So when we book 10 to 20, what should we return here? So 10 to 20, there is no overlap yet, right? So we have only one booking, so we return 1. That's what we return here, okay? When we book 15 to 16, still no overlap, right? No intersection, so only 1, because each of them has 1, so we return 1. Now we book 10 to 40. 10 to 40 is like this, so 10 to 40, something like this, maybe, okay? So now you can see we have an intersection here between these two. Here, okay? So, and that's the max one, 2 and 1. So we return 2 here. And now we take a look at 515. So 515, 5 would be somewhere here, and 15 would be somewhere here. Now you can see in this position here we have 3 bookings. So now 3, 2 here, and then 1. So we return 3. 510. So 510, we want to do 5 here, 10. Remember, start is inclusive, right? So what this tells us is that we have all of these. Okay, let's see why we have this one is not inclusive. Yeah, sorry, so the ends are not inclusive. So what this would mean is that this is not inclusive actually, right? So what this means is basically there is no intersection here, because 10 is the end, so it's not inclusive. So this interval actually has up to 9. That's where it's inclusive, right? So here we have 10 here, 10 here, and then the 10 here, so 3 as well. So that's why we return 3 here. Now we add 25, 55. So if we add that, 25 should be somewhere here, and then 55 should be somewhere here, right? So now this actually intersects with here, right? Somewhere here, 25. It intersects with this 25, and it intersects with this 55, right? So here, with this here, we'd have just 2. With these intersections, we have just 2. And so the max is still 3. So notice that it's not just like the intersection with this booking, it's what the max in all of the calendar so far. And here it's still 3. Now, just looking at the drawing I did here, there's a quite known technique called line sweep that exactly does this. Which is basically just, since these are horizontal, you can think of like a vertical line that is sweeping all of the intervals. And how do we know the max? Well, we know that when you start an interval, now that intervals, if there is an intersection, it increases the max. But when you reach an end, right? Now, especially here, because it's open, if there is a max, let's say 3 involving this interval, it decreases, right? Because this interval is no longer ended, so we need to decrease. And so what we can do with this line sweep technique is just every time we encounter a start, so for a start we increase by 1, but when we encounter an end we decrease by 1, right? And if we do this, well, we should be able to just go through it. If we encounter 2 starts, then we would add 2. If we encounter 3 starts, then we add 3, and this 3 value will stay there until we reach the end, then we will decrement it by 1, and now we have just 2, right? So that's the idea. So that's what we can explore here. And what we can do basically is just maintain some sort of array or a map of time, let's call it, and we can just go through our intervals for each booking. Actually, we can just use so a booking will have start and an end. We can just say time at start increased by 1 and time at end decreased by 1. If this was a closed interval, then we will mark only end plus 1 by minus 1, because the intersection can be at the end, right? But since this is an open one, at the end we decrease at E exactly. And now what we can do is, once we have the times, we can just sort them and just go through them, right? And when we go through them, why do we sort them first? So we sort them by keys, by the way, S and E. So why do we sort them? So that the line sweep here, the vertical line sweep, right? What does it do? It goes from the start, and it just keep going horizontally in order, right? Because we don't want to compare this and this. We want to compare it in sorted order. So that's why we do the sorting here. But this sort, since this is a map, time would be a map, it would be using the keys here. So it would be using S and end. And as we traverse, we just want to keep a value of the current line intersections. How do we do that? So we can just go through, let's say T in sorted for time. And this is, by the way, this is a map. And this is sorted by keys, by start and an end, right? So we can keep the value of like the intersections, let's call it current. So this would be the intersections at point T so far. And every time we just add current plus time at T. What this will do is that here we would have it at 5. So first, when we encounter the first 5 for the first booking, it would be 1. When we encounter the second 5, it would be 2. And then when we encounter the end here at 10, the current would be 1, because now there is only one intersection. But then when we get this 10, we would increase it by 1, because now there are 2 intersections. When we get here, we increase it by 1. Now there are 3 intersections, right? So current, just at that line, how many intersections we have. And so since we want the max for each booking, we just compare it with the bests we have so far, right? So let's say we initialize our best to 0. We'll compare the current number of intersections with the best we've seen so far. This is for cases like the last interval where it's 2. We want to return the best we've seen so far, which is 3. Okay? And then we return the best. And that's pretty much it for this solution here. So you can, the main thing here is to learn line sweep and learn that as we do have this vertical line sweeping, we can keep track of the current number of intersections. Yeah, so I think that's pretty much it for this problem. So let's code it up and make sure it passes our test cases. Okay, so let's implement this solution here. So the first thing we need to do is create our map that keeps track of the intervals. So this would be just to avoid like having to check if the number is there. We can initialize it to int so that if a number has not been added, it's 0. And then here, when we want to book a number with start and end, let's just call this s and end for simplicity. Then what we said is that for s, the start, we want to increase by 1. For end, we decrease by 1 because that's the end of the interval. This is not included, so we remove it. And then we want to sort self.time. So we can actually just, when we are traversing it, do self.time and explore for each vertical line sweep how many intersections we have. So let's say current is the intersections here, and then we just add t. So that would be adding either 1 or -1. And we do best is going to be the max of what we've seen so far and the current number of intersections. So let's just initialize best here, and then at the end we return best. So the implementation itself is pretty straightforward. It's merely visualizing how to apply it here. And in terms of time, this would be O of, let's say n is the number of bookings. So that's up to 400 number of calls to book. So the number, what we have in time would be maybe 2 of this, right? Because, so 2 multiplied by n here. And since this is sorting, this is log 2n. So roughly it's n log n. So we sort first and then we traverse. So n plus this. So roughly n log n is the time complexity here. In terms of space, we are using O of n extra space, or O of 2n, which is roughly n, because we add every s and e. And n is quite small, it's 400, so this should be reasonable. So let's run this. Unless okay, looks like, yeah, this should be self.time, sorry. Okay, let's run this. Okay, sorry, this is not adding, we don't want to add s or e actually. We want to add the values because that's what the intersection represents. My bad. So let's run this and let's submit. Okay, so that passes test cases. Yeah, so very good application here of line sweep technique. Yeah, please like and subscribe and see you on the next one. Bye.